Okay, so the point of this video, I think this is going to be video 50, but the main point is constructing the cost function and an example problem. The example problem is kind of the main purpose, so we'll try and draw that on the board. But shortly, they construct the cost function, and we have to kind of know intuitively what came before, so it can be a little bit ambiguous. But we use graphs to intuitively discuss how to compute the optimal amount of inputs that the firm should use, given input prices and target output. These are functions L. So what they do is they have labor as a function of W, R, and Q. So, I mean, you can change W, R, and Q. Those are supposed to be constants, maybe not. But they do it here where the labor is a function of a wage. R is kind of like that rent thing for capital, and Q quantity. Yeah, and then they have a capital the same as a function of a wage, rent, and quantity. Yeah, as opposed to L and K are a function of quantity. Now quantity is a function of L and K. You can, of course, reverse it. But I do agree. I just don't want to dwell. I tend to do that, and it takes a lot of time. How they how they illustrate labor and capital are kind of ambiguous, and then the cost function is just the same as it always has been, plus RK, but now they're calling L and K a function of all that stuff. Yeah, all that stuff is certainly in there. But if you kind of read through that little bit, that's how they construct the cost function. Okay, so we can kind of walk through now numerical example. We can read through it, but numerical examples, consider the following three numerical examples. In each example, we have two goals. Given an output target Q, find inputs L and K that minimize cost, right? The cost function. The most important, of course, is to Cobb Douglas, and that's what it's going to be. And it's the first one that we went over, so let's just kind of go through this here. Yeah. So remember condition 2. Condition 1 does not matter. Condition 1 just kind of states the quantity function, but we are going to use that condition 2 down at the bottom right there. Yeah. So they're going to have this somewhere. Let's see. It's always correct. In a perfectly competitive market, a firm has production function quantity equals that. We know from the style that it's obviously Cobb Douglas. They give us input prices are wage equals 20, rent equals 5. For target Q, find L star, K star, and C. So that's the whole point. So instantaneously, with all these problems, what we do is we take the partial of Q with respect to L and the partial of Q with respect to K. Yeah. So we no longer kind of explain, that's a plus. We no longer explain these things. That right there is a mistake. I see K over L, the square root is what I see. Yeah. So let's just take a look at something here. Did they kind of take the derivatives? Yeah, so they take the derivatives right there. I'm just kind of giving my interpretation of the derivatives. So we can write that down if we want to. It should be correct. Yeah. That was with respect to L. So kind of silly when we kind of give it a run through. The partial with respect to K is the exact same thing. Yeah, flip it. Yeah, so it's going to be the 1/2 comes out front. That's where the 25/2 comes from. It's L to the 1/2 K to the negative 1/2. Therefore, it equals 25/2. This one is going to be L over K, the square root. That's what that's going to be. Okay, so with all these problems, we state these conditions, but we're always doing that just to make it clear, we are constructing this, yes? So remember W and R, they gave us W and R, yeah. W is 20, R is 5, 20 divided by 5 is 4. Yeah, so we take those partial derivatives. The partial derivatives are the MPL and the MPK, where it's MPL over MPK. So what's next? We put that over each other. They have the 20 over 5. So we just did this. Yeah, it simplifies to be this. If you divide one over the other, it will simplify into be that right there. Yeah. So we can kind of quick write out the math for that for fun. Yeah, what did I get? Remember the 12.5 is the 25 over 2. Yeah, and I had said that we get K over L, the square root. We don't have to write it how I write it. We can write it how they write it. And then I said that we get L over K, the square root. That was my argument. The 12.5 is obviously gone. Yeah, so we have K over L, the square root. How do you divide by a fraction? It goes up top and flips. So L over this goes up top, and it's another K over L, the square root, and blah, blah, blah. We get K over L, the square root squared. Just doing math everywhere, and we get K over L, which is what they got. So it doesn't matter at all how we do the algebra. And then you have to set it equal to 4, 20 divided by 5. So you take the derivatives, we plug them in here, and we just do that right there, yeah. Okay, so that's good there. And then we get the understanding that K equals 4L. Okay, so we want to follow the steps. It's more like repeating the steps always in a math problem as opposed to understanding. But the original Q of L comma K, yeah, equals 25. I don't like decimals. If you're a math person, you just really don't like decimals. It doesn't matter, decimals or fractions. If we're a computational person, we actually love decimals, which is why they write it that way, because it's probably better to put it in decimals. Well, what are they going to do? They're just going to plug this in for K, yeah? What in the heck did I write there? Yeah, so K becomes 4L, the square root, yes? So can we kind of simplify that in our heads? Doing math at the top now. I get 25, the square root of 4 is just 2. And then we get the square root of L times the square root of L, which is just L good. So we get 50L is what I got when we plug that in. So it's always like that in videos where if anything is important to us. Yeah, so they got 50L. Okay, so that's L star is Q over 50. So they go back and they plug that into statement K equals 4L. Yeah. And then we get K star, which is 4Q over 50. Okay, it's a very, very simple math problem, but it always takes me about, more than 10 minutes to go through it. So if we kind of talk through this, it's going to have to be in a different video, and then we will go on to example 2.